Hi, I'm Jeffrey Lojano. I'm a student in Calculus 2, Mac 23112, and I'm here to teach you guys about ratio tests. So you may ask, what is ratio test? Oh, don't worry. It's a method used in calculus to determine if an infinite series converges absolutely or diverges or is inconclusive as well. Now, the plus side to this test is that since it finds out if it converges absolutely, it also means that if it converges absolutely, it also converges regularly. Um, Yes. It does this by calculating the limit of the problem, and if it equals anything about one, then it's converges or diverges. It works both for positive and alternating series due to its absolute rule, and we can go more into that into detail into this video. But the only downside is that when the limit equals equal to one, that is inconclusive, which means that you can just use another test. And yes, here is an example of what ratio test would look like. We see here how we have the equation a then approaches infinity from 1. What you would do is you would take the general term and you would add 1 to all the nth terms. And then once you have that, you would divide it by a of n and in its absolute value. And then once you take the limit of that, the result is your answer. So if the result is less than 1, the the original problem converges. If it's greater than 1, it diverges. And sadly, if it's equal to 1, then it's inconclusive. How? Ooh, sorry. What happened? Excuse me. Technical difficulties. Okay. How to use it? So first, you have to find the general term, which is a of n. This is usually the problem after the subscript, the sum of it. Um, and when to use ratio tests, you would use it when you have exponentials of n as 3 of n or e to the n. It makes it fairly easy to cancel out and come up with your limit. N factorials are very easy once you get the hang of them to factor out and cancel, and also n to the powers of n as well. There's also another test known as root test, where if you have like multiple factorials of n or exponential values of n, it would cancel out. But you can learn that in I'll teach it in a later video. The second step would be to find a of n plus 1, which consists of adding a of n plus 1 to all the nth terms from your general term. So this may be, no, how should I phrase this? You should be tricky. Should take caution when you're doing this step, because if you don't do it properly, then when you distribute, you wouldn't get the right answer. So an example I have here is 2 of n plus 1. So whenever you're including n plus 1 in a term like this, where it's being multiplied by another term or added, you should put the n plus 1 in parentheses, like here, and then distribute accordingly. That way you prevent any confusion or any uh, improper distribution of it. And here in the example, we have 2 of n plus 1. So when we add n plus 1, we put that in parentheses. So then we would distribute the 2 to the n and then the n and the 1. And then you add the 1 in the end, and you would get 2n plus 3. Here are the continued steps. Once you have your a of n plus 1 and your a of n, you would put them in the ratio to form it. And when you do this, you also have to remember to put in the absolute value to take away any negative terms. This is why it works for alternating series, and then you simplify the ratio. It's not as simple. Usually, it's not as simple as it sounds, but you would factor out the terms for or you would expand the terms for factorials, expand the terms from when it's to the n plus 1 over divided by n factorial, or the n exponential values of n. But once you have the simplified to the best of your abilities, then you would take the limit of that ratio, and then the result of the limit is when you would apply the conclusion, which would be um, if it's less than 1, it converges. If it's greater than 1, it diverges. And if it is equal to 1, it is inconclusive. Here we have an example of what you can do. We have the infinite sum of 3 of n, 3 to the n factorial over n factorial from 1. So first we have to find the a of n, which is pretty simple. It would be the term 3 to the nth over n factorial divided by 3 to the n factorial. 3 to the nth over n factorial divided by 3 to the nth over n factorial divided by 3 to the nth over n factorial divided by 3 to the nth over n factorial divided by 3 to the nth over n factorial divided by 3 to the nth over n factorial divided by 3 to the nth over n factorial divided by 3 to the nth over n factorial divided by 3 to the nth over n factorial divided by 3 to the nth over n factorial divided by 3 to the nth over n factorial divided by 3 to the nth over n factorial divided by 3 to the nth over n factorial divided by 3 to the nth over n factorial divided by 3 to the nth over n factorial divided by 3 to the nth over n factorial divided by 3 to the nth over n factorial divided by 3 to the nth over n factorial divided by 3 to the nth over n factorial divided by 3 to the nth over n factorial divided by 3 to the nth over n factorial divided by 3 to the nth over n factorial divided by or not sorry, but then once we have the general term, then we would add n to the term, which would be 3 of n plus 1 over n plus 1 factorial. Now, because n factorial is just being multiplied by n, you wouldn't have to put the n in parentheses, or you would because it's being multiplied by the factorial. Yes, yes. So once you have a of n and a of n plus 1, then you put them in the ratio. So you would end up with 3 of n plus 1 divided by n plus 1 factorial divided by 3 to the n of n factorial. Now, because you're dividing fraction over a fraction, it'll pretty much being multiplied by the reciprocal. And then you will start simplifying. 3 of n plus 1 can be canceled out by 3 of n, and you'd be left with the variable or the constant 3. And then n plus 1 factorial also cancels out by n factorial. So then you would get 3 times n plus 1, or 3 times n over n plus 1. And then you take the limit of that. In some situations, like when you're finding the radius of it, or the interval convergence, you would factor out the constant. But in this situation, we don't. So we just leave it as 3 over n plus 1. And when we take the limit of that, we get 0. And since 0 is not equal to 1, that means that we can look at it as a value of less than 1. So it means that this term or this problem converges absolutely. For example 2, we have the problem as it approaches, 2 of n factorial divided by 5 to the nth power, expanding infinitely as n equals 1. And for this, we have to find the general term, which would be 2 of n factorial over 5 to the nth power. And then, we would add 1 to the n terms. So we would have 2, and you see here, since n is being multiplied by a constant of 2, we have to put it in parentheses in order to prevent any incorrect distribution. So we would have 2 parentheses n plus 1 close parentheses factorial divided by 5 to the n plus 1 divided by the original general term, which is 2 of n factorial divided by 5 to the n. In this example by Grok AI, they simplified they put it over like terms and distribute the fractions out. So to cancel out the 2 of n plus 2 factorial, what you would do is you would expand out the terms, as you see down here, where you would get 2 of n plus 2 times 2 of n plus 1, and then to 2 of n factorial. So then those two would cancel out. And same thing with the constants, 5 of n plus 1 over 5 to the n. These, when you expand it out, it would be 5 to the n times 5. Times 5. And then the 5 n's would cancel, to the nth would cancel. So you would be left with 2 of n plus 2 times 2 of n plus 1 divided by 5. And then once you take the limit of that, it's to infinity, which is greater than 1. So then this series diverges. Thank you for watching. I hope you learned something new. This was a very fun video to make. It was very exciting, and then to answer the questions, for AI, I use Grok AI to help me create the examples for this problem or for this presentation. I liked it. It was very simple to use the format. Just say give me an example of ratio tests. I didn't like I could have. What I didn't like was how the formatted the problems and wrote them out. But I feel like I could have been solved by just writing the the prompt differently. For my self-reflection, this did help me understand calculus 2 specifically for ratio test, and I feel like it was very helpful. And it did help me prepare for the final exam, which I do feel a little bit more prepared for, which I'm looking forward to take soon. So thank you very much. My name is Jeffrey. I hope you enjoyed this video, and I hope you learn how to do ratio test.